Assalamualaikum warahmatullahi wabarakatuh. Group 8 login to present on chapter 9 of carbonyl compound. So before we continue with the presentation, let me introduce to you our group members. This group consists of 5 students, which is Ali HUSAENI with the metric number 9201011, DANISH IRFAN 9201008, and the third one, HUMAIRA 9201001, SOFEA 9201004, and the last one is LIYANA 9200989.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ali HUSAENI bin ABDUL RAZAK, and I would like to give a presentation. And the question is, an optical active compound U C10H14O gives a positive ion form test and form compound V C10H12 when it reacts with heated concentrated sulfuric acid. So this compound U is alcohol because the name of the compound U is 3-phenyl-2-butanol, and this alcohol will produce alkene when it reacts with heated concentrated H2SO4, which is sulfuric acid. So that means the compound V is alkene, C10H12, and the name of compound V is 2-phenyl and 2-phenyl-2-butane. So the structure is of compound U is this, and this is the structure compound of compound V. And proceed to question. The ozonolysis of V yields compound W C2H4O and compound X C8H8O. Both give positive iodoform test. The reduction of X produce 1-phenylethanol. Determine the structure and name the compounds U, V, W, and X according to the IUPAC nomenclature. So let's proceed to next slide. Alright, as we know, the ozonolysis of V, which is alkene, will produce compound W and compound S, which are the compound W is aldehyde and the compound S is ketone. And the region of this ozonolysis are O3 and zinc H2O and H+. And we know from the question that compound X will produce 1-phenylethanol with a reduction, and we know that we use the NaBH4. So the name of this structure of this compound W is ethanol, and the name of structure compound X is 1-phenylethanol.
Assalamualaikum warahmatullahi wabarakatuh. My name is SOFIA BINTI, and I am going to give a presentation for the next questions. The question asks for the observation for the iodoform test and name by the byproduct that gives the observation. So for the observation for this test, there is a yellow precipitate of the triodomethane CHI3 occur. Okay, as you can see in this slide, I put some example of the yellow precipitate there, and the byproduct for this test is sodium iodide and H2O water, and also triodomethane CHI3. Okay, next slide. Explain how compound W and X can be distinguished by giving a suitable chemical test, equations, and observation for both compounds respectively. So, to distinguish between these compounds, we choose to use the Fehling test. The equation for compound W, which is ethanol, here you can see CH3 ethanol here, will react with Cu2 plus and produce an acetic acid together with copper 1 oxide and also H2O. This is for compound W. For compound X, which is 1-phenyl ethanol, react with Cu2 plus, and there is no reaction occur because the compound X is a ketone while the W is a aldehyde. So the observation for ethanol or compound W during the test is oxidized to carboxylic ions as Cu2 plus is reduced to copper 1 oxide Cu2O, which is yellow precipitate. Thus, the blue color solution turns to brick red precipitate. And for 1-phenyl ethanol, which is X compound, during the test, no reaction occurs and the blue color remains.
Hello everyone. Hi. Assalamualaikum. My name is HUMAIRA binti SOFIAN and my metric number is 92010001. So I'm going to continue with the presentation. So let's move to the question over here. Okay. So the question states that in another reaction, compound X reacts with HCN. State the type of mechanism occur, write the chemical equation, and show the reaction mechanism. Okay, so from this question, we know that it requires us to do three things, which is we need to state the type of mechanism occur, the chemical equation, and show the reaction mechanism. Okay, from the previous question, we already know that compound X is a 1-phenyl ethanol or acetophenol. So this is the compound of 1-phenyl ethanol and it is a ketone. Alright, so we already know the compound X. Now we need to know the type of mechanism occur when compound X reacts with HCN. So what is the type of mechanism occur? Can you guess it already? Yes, it is a nucleophilic addition mechanism. Alright, so we are done with the type of mechanism occur. Let's move forward to the chemical equation that is involved. Alright, so this is the chemical equation. So basically, the reactant over here, which is the 1-phenyl ethanol, is going to react with the reagent hydrogen cyanide to produce the product 1-cyano-1-phenyl ethanol. As you can see here, the CN is attached to the carbonyl group, and also the OH, which is the hydroxy group, also attached to the carbonyl group. Okay, so let's see the name of the compound. So basically, the reactant 1-phenyl ethanol is going to react with the reagent hydrogen cyanide to produce the product 1-cyano-1-phenyl ethanol. Okay, so we are done with the chemical equation involved. Let's move forward to the reaction mechanism. Okay, so we're going to continue. Based on the previous question, we already know that the type of mechanism is the nucleophilic addition mechanism. Okay, so we're going to see the reaction mechanism. So basically, the nucleophilic addition involves of two steps. So what is the first step? Yes, step 1 is the nucleophilic attack. Okay, so first thing first, what we need to do is we need to identify which one is the electropositive part and the electronegative part. So basically, this is the electropositive part and this one is the electronegative part. Then the electropositive part, which is the carbonyl carbon, is going to be attacked by the nucleophile. So basically, Cn minus is going to attack the carbonyl carbon. Okay. Then the double bond over here is going to lose the electron and give it to the electronegative part. So basically, this is a slow reaction. So don't forget to write it, slow reaction. Then we're going to get the intermediate whereby Cn is going to attach to the carbonyl carbon and also the oxygen will be negative charge. Okay, we are done with the step 1. Let's move to step 2, which is the addition of proton OH+. So basically, the H plus is going to be attacked by the oxygen, or the negatively charged oxygen is going to attach the H plus over here. And this is a fast reaction. So don't forget to write it, fast reaction. Then we're going to get the product whereby Cn is going to attach to the carbonyl carbon, and also the hydroxy group OH also attached to the carbonyl carbon. Okay, so we are done with the step 1. I hope all of you can understand all of the questions and answers very well. So let's move to the task 2.
Hi, Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is SHAHARUDDIN. Now I will present to you about task 2. For task 2, the question is you need to choose one type of plant that has been mentioned in Al-Quran and related to the functional group that has been presented in task 1. So, for this task, we choose jasmine as our plant. It is because the jasmine functional group is ketone. For related Quranic verse from Surah Ar-Rahman, chapter 55, verse number 12. أعوذ بالله من الشيطان الرجيم. والحب ذو العصف والريحان. It means and field greens and fragrant flowers.
Assalamualaikum warahmatullahi wabarakatuh. My name is LIYANA binti ZAINOL with metric number 9200989. So based on the question given, determine and find out any active component present in that plant and then select one component. Give the organic structure and IUPAC name of the component that you choose. Describe the composition and benefits of the component. First, the active component from jasmine plant is jasmine, or also known as ZAC jasmine. The IUPAC name of this component is ZAC 3-methyl-2,2-pentenyl 2-cyclopentenone. And the molecular formula is C11, H16 and oxygen. Okay, so we can see here that the organic structure of jasmine is like this, and as we can see here, the functional group here is ketone. Okay, next we proceed with the composition of jasmine. Jasmine contains 8 calories per 100 gram serving. One serving contains 0 gram of fat, 0 gram of protein, and 2 gram of carbohydrate. The latter is 1.7 gram sugar and 0 gram of dietary fiber. The rest is complex carbohydrate. Jasmine contains 0 gram of saturated fat and milligram of cholesterol per serving. 100 gram of jasmine contains IU vitamin A, milligram of vitamin C, and mcg of vitamin D, as well as milligram of iron and milligram of calcium, and also milligram of potassium. Okay, next we will go through to the benefits of the plant. Okay, here is example of the jasmine plant. Okay, wait a minute. Okay, before I want to go through to these benefits, I want to brief a little about jasmine. Jasmine is a plant whereby jasmine is a component of the vapors from jasmine flowers with yellow liquid. It smells like jasmine, which has a woody, herbal, and floral smell with a citrus nuance. Okay, in medication, jasmine has been used for liver disease, hepatitis, liver pain due to cirrhosis, and abdominal pain due to severe diarrhea or dysentery. It is also used to cause relaxation as a sedative, to heighten sexual desire, and as aphrodisiac, and also used in cancer treatment. Jasmine is also can use in foods. Jasmine is used to flavor beverages, frozen dairies, desserts, candy, baked goods, gelatines, and puddings. It is also food additive in the form of spices, extracts, and also colorings. In manufacturing, jasmine is used to add fragrance to creams, lotions, and perfumes, cleaners, laundry products, and also air freshener. So I hope that you guys can learn a bit about the benefits of the jasmine plant.